Solving quadratics by factoring and graphing, part 2. Sorry about the first part. I was interrupted and I wasn't able to finish. Okay, so in this one we've got a right triangle. And then we've got to interpret what it is it's saying. The shortest leg of the right triangle is 7 inches shorter than the longer leg, so we're going to determine that the longer leg be x plus 7. We'll go ahead and assign the short leg the value of x, and it says that the is 8 inches shorter than the hypotenuse, so we're going to use x plus 8 for your hypotenuse. Pythagorean theorem, a squared plus b squared equals c squared, x plus 7 squared plus x squared plus equals x plus 8 squared. Perfect square trinomials, x squared plus 14x plus 49 plus x squared equals x squared plus 16x plus 64. Subtract these entire values to the other side. Alright, cancels, and you come up with x squared minus 2x minus 15 equals 0. Factor that out. Two numbers multiply together to make 15 and add up to 2 are going to be x and 3, x and 5, and that's got to be positive 3, negative 5. Therefore, the answer is x equals negative 3 and x equals 5. In the context of this problem, it cannot be both because the distance x cannot be a negative number. Therefore, the answer is 5. Using the table below, we're going to find possible solutions to this problem. So the first thing we've got to look for here is the place where the y values switch from positive to negative, because that would be the place where the graph itself crosses the x-axis. That occurs between these two values here. Rough estimate here would be negative 4.75 as one of your solutions, and the other rough estimate here would be negative 3.5 as your rough solutions. So you've got to understand and interpret tables as well as looking at graphs or simple equations. The vertex of the parabola is located between the 2 points of symmetry. So notice we have symmetry all the way through. This point is symmetrical to that point, again here and here, and once again here and here. This symmetry right here is the location of the vertex. Therefore, the vertex is located between negative 4.25 and negative 4. Looking at 9, 10, and 11, we're going to look at different types of factoring in order to solve these problems. So notice this is a perfect square trinomial. That is going to be x plus 5 quantity squared. That means that I'm going to set each one of those equal to 0, and you get x plus 5 equals 0, x plus 5 equals 0. Redundant, yes, but just remember that you're writing it 2 times. Therefore, the answer is x equals 5. Please remember to move all your values to the same side. 6x to the 4th minus 600x squared equals 0. Take out your greatest common factor of 6x squared, and what's left is x squared minus 10. Set both equal to 0. 6x squared equals 0, and x squared minus 10 equals 0. Divide out the 6, square root 0, and we get 0. Add the 10 to both sides. X squared equals 10. When you square root a value, you always have two solutions. Therefore, the answer to this is x equals plus or minus the square root of 10. The three solutions to this problem are x equals 0 and x equals plus or minus the square root of 10. In this final problem, we're going to use four-term grouping to help us get the right answer. So we'll write it in descending order by moving both the 3x squared and the 12 to the left side of the equation. X to the third minus 3x squared plus 4x minus 12 equals 0. Four-term grouping, put your parentheses around the first two terms, follow up with the last two terms, factor out your greatest common factor, which is in the first term, or the first group, binomial is x squared. What's left is x minus 3. In the second group, you factor out a 4. What's left is x minus 3 times 4. Then your answer is x squared plus 4 times x minus 3 equals 0. You're going to do x squared plus 4 equals 0, and x minus 3 equals 0. Subtract 4 to both sides, and you get x squared equals negative 4, and add 3 to both sides, and you get x equals 3. What comes next is imaginary. Oh, it's very real, but we have imaginary solutions. Square root both sides, and you get x equals the square root of negative 4. Now remember, the square root of negative 4 is a non-real solution, so we must involve the letter I. So that is going to be plus or minus 2i. And here, x equals 3. Those are your solutions for this problem.